electronegativity. So let me share my screen with you. We'll jump right into this questions here. And let me get myself pulled up. Okay, so here we go. What type of bonds exist between metals and nonmetals? So if you are unaware, you need to be aware, become aware the fact that there is a dividing line over here. And basically, it's these green versus yellow over here. And these are all your metals, and these are all your nonmetals. The metals, those are the ones that are going to give electrons. The nonmetals are ones that are taking electrons. So they work together to form what we would say is ionic. They form an ionic bond. And if I have both nonmetals, well, that means they're both takers. So that doesn't work. So they'd both be the yellow on the right. So that means nonmetal, nonmetal, those are going to be covalent bonds. Okay, now I want you to use the chart for two questions, for the K and the O and for P and SE. K and O, so let me circle those, K and O and SE and P. I'm going to erase that line. Maybe I'm going to erase this line. Let's see if I can erase this line. I don't know why it's not working. Let's see if that, there it goes, finally. Okay, just a little slow. Okay, so let's do the math. K and O, very slow. K and O, I've got K being 0.82 and O being 3.44. So 3.44 minus 0.82. Subtract. And what you get is 2.62. All right, let's go ahead and do the same for the P and SE, and the number is significantly smaller, 2.55 minus 2.19. It doesn't matter. It's absolute value. You always use the larger value to start. So I've got a big difference and I have a very small difference. So right off the top, you should be able to see that K and O, those are metal, nonmetal. It's ionic. You already know that because of the difference and where they are. So that one was a very easy one for you. So this one is a ionic bond, but we have proof of that mathematically because this value is greater than, whoops, this value is greater than 2.5. 2.5 is greater than the value. So if it is 2.5, that means, or greater, that means it's going to be polar. Now, if it is 0.5 or less, which this one is, that means it's going to be covalent. If it's somewhere in between that 2.5 and 0.5, it's going to be called polar covalent. So we've got nonpolar on this one. This one is nonpolar, and we have proof now mathematically. And this is what I was hoping that you would be able to pull information-wise from the lesson that we did last time. Thank you very much. I'll talk with you again very shortly. Talk to you tomorrow. Bye.